also known as contingency table or cross tabulation, and it is a type of table that displays the frequency distribution of variables. Now if you don't have any statistics background, you will be like, what the heck is frequency distribution of the variables? Let's look at the example and try to understand this. I have this survey data where there are different individuals from different countries, and this data set has their sex and age along with their handedness. It tries to show whether they are right-handed and left-handed. Now for your business analytics or your research purpose, it might be useful to have this two variable table where on the x-axis you have a nationality and on the y-axis you have whether individual is right-handed or left-handed. Or you could have the sex, like male or female, on the x-axis, and the y-axis can indicate the handedness of the person. And these two tables are basically your contingency table or crosstab, and Pandas crosstab can help you generate these tables very easily. As usual, I have run Jupyter Notebook command on my command prompt and created this notebook right here. And I am reading this Excel file using Pandas read Excel method. And when I execute it, I get this nice data frame right here. Now to create the contingency table, I need to call crosstab method. Now remember, the crosstab method is on Pandas, it is not on data frame. So I'm doing pd.crosstab, and then here you specify the variable that you want to put at a row level or on the x-axis. So for my first table, let's say I want to have nationality, and in columns I want to have, let's say, handedness. When I run this, I get this nice table. So I have two individuals from Bangladesh who are left-handed. So if you look at this, you will see that both of the individuals from Bangladesh are left-handed. Similarly, USA has 3 people who are right-handed, and you can see that. So this is showing the frequency of that variable. So now you understand what is frequency. So frequency is like number of occurrences, and the variables that I have used here are nationality and handedness. You can also put sex on x-axis, and when I run this, now I have a table saying how many females are left-handed versus right-handed and how many males are left or right-handed. Okay, now there is another argument that you can use in crosstab method to generate the total, and that argument is margins. So if you supply margins to be true, what will happen is it will also show you the total. So here I have 2 and 3, and this is the total of these two, and on the column level also I get these nice totals. Okay, now what if I want to have multiple variables? So here I have only 2 variables. Let's say at a column level I want to have the nationality also. Okay, so that you can do it by passing this as an array. Okay, so here I can have df.nationality, and when I run it, now I know how many left-handed people are from these different countries and their frequency distribution. Okay, you can do the same thing at x-axis. So I can plot nationality at row level also by just supplying it in your array. Okay, so now nationality is at x-axis. So I have country and then the sex and their frequency distribution. Okay, now let me revert this back to my original data frame. Here it is showing the frequency distribution. Sometimes it's good to have percentage instead. So for doing that, there is one more argument. Now I'm not sure what that argument is. So I'm going to open the documentation. Now I'm going to tell you a nice shortcut in Jupyter Notebook. It is Shift Tab. So when you press Shift Tab, it is gonna open the documentation on that method. So here Crosstab has all these arguments, and one of the arguments here is normalize. So if you look at the documentation of normalize, it says that normalize by dividing all values by the sum of values. So if you want to do a percentage at a row level, you will pass the value to be index. So I'm going to now supply normalize argument, and the value will be index. So when I do that, what I'm getting now is the percentage of the individual value. Okay, so let me just show you just to have that comparison. So I'm just going to copy this here and pass normalize to be index. So here you can see that, and here let me put margins just so that you get a perspective. So here you can see that this is 40%, this is 60%, this is 71%, and this is 28%. Okay, now what I'm going to do is I'm going to use one more column that we have in our survey data, which is age. Now let's say you want to know the average age of these individuals in context of your contingency table. So let's say I have this table right here. Okay, and now I want to know the average age of females who are left-handed. Also, I want to know average age of males who are right-handed, of course in the context of the survey data that I have. So for that, you can supply values arguments. You can say values is equal to df.age. So age is your column. Okay, so you want to analyze these values, and then the information that you want to get out of it is the average. All right, so you will say aggregate function is equal to np.average. Now np is the numpy module, so you need to import it. So I have imported it here, and when I execute it, now see I'm finding that the average age of females who are left-handed is 44.5. Okay, so if you look at all your females here, let me just prove that. So I am looking at all the females. Okay, and all the females who are left-handed. So here I'm going to select left, and if you look at their average age, so here you can see that 44.5. so that's what I get. And if I change this to right instead and look at the average age, their average age is 31, which is what you are seeing here. There are many other statistics you can do. You can just look at the documentation on numpy functions. Again, don't forget to use Shift Tab shortcut to look at the documentation on any method. All right, I have provided the Jupyter Notebook that I have used in this tutorial in the video description.